We are given a function 1 over x squared plus 1 and asked to find f of half, which means that we substitute x for 1/2 into this function. So f of half will be equal to 1 over 1/2 squared plus 1. And we could simplify that to 1 over, and now a half squared will be 1/4, and then we're adding 1, so it's 1 and 1/4, which is also 5/4. And if you do 1 divided by 5 over 4, that would be the same as 4/5. But you could put that into your calculator and give it as a decimal if you wanted to. It wouldn't matter either way. Now for part B, we're given a function g of x and asked to find f g of x as simply as possible. I'm just going to write here f of x was 1 over x squared plus 1, just for our reference. Now when we have composite functions like this, we have to apply the first function first, and then we apply the left function afterwards. So what this means is we're actually going to end up replacing the x in the f function by the whole function g of x. So wherever we find a x in the f function, we will replace it with g of x, which is root x minus 1. So that would mean that instead of having a 1 over x squared plus 1, we'll have 1 over root x minus 1, and we still need to square that plus 1. So all I've done is I've replaced this x with the function g of x, and we're just going to do a little bit simplification because it wants to give the answer as simply as possible. So on the denominator here we've got two operations that are inverse. We've got the square root, and then we want to square that, so they cancel each other out, and that is simply left with x minus 1, and we still have that plus 1 on the denominator, which will cancel out, leaving us with 1 over x, written as simply as possible.